Now, I think the nice thing about this exam is the questions aren't getting harder as it goes on. If anything, getting a little bit easier. So Kara's got a starting salary of 20,000. She's getting a bonus the same amount each time. That means it's an arithmetic series. So the first thing to do is just to write down that we've got our A is 20,000, our D is 500, and just remember to look in your formula booklet, and arithmetic series gives us those two different ways of finding the nth term. Sorry, the sum of the numbers up to it, and the nth term is within it. I'll pop that down again in a moment. So yeah, I mean, yeah, just as a reminder, the sum of the nth term, it does say, is a half times the number of values, and then it says 2a plus n take 1d. And remember, the nth term is just the a plus n minus 1d. You can use the normal nth term as we did in GCSE if you like at that point, but in terms of working out the sums of things, this is really, really handy. So the first thing we want is the total she earns in the first 10 years. Well, before I do that, I'm going to find out how many years it takes to reach that, because I think that's important. So we can do that by using the basic nth term thing, which would be 25,000 is going to be equal to your original one. So this is where I'm saying a plus n minus 1d is your nth term. 20,000 plus n take 1 times 500 is my difference, isn't it? Take 20,000 away from both sides gives us 5,000. Expand that bracket gives us 500n take 500. Add 500 to both sides gives you 5,500 equals 500n. Divide by 100, then divide by 5 gives you the 11th year. Basically, the 11th term or the 11th year is when she's going to hit it. So for the first 10 years, it's just going to be using this formula. So the total for the 10th is going to be a half of 10, and then we'll have 2 times a, so that is 40,000 plus n minus 1, which is 9, isn't it, times 500. Smack that into your calculator and you should get £222,500. Then part B, already done the sort of tricky bit here by working out that the 11th year is going to be 25,000. So we're going to have the 10 years, 222,500, and then we're going to have 5 years of, because the 11, 12, 13, 14, 15, yeah, 5 years of of not of 500, of 25,000, isn't it? Put that into your calculator and that should give you 347,500, which just leaves us with one reason why this may be an unsuitable model. Now, the reason I came up with was this. That inflation over time would mean that after 20 years, because she's getting the same amount of money as she was after 15, she would effectively be paid less because things would cost more 5 years later. However, when I looked in the mark scheme just said it's unlikely that you would get exactly the same pay rise every year. And that's all it said. It says here, state one reason why this may be an unsuitable model, and it would always accept any reasonable idea. So if you've got anything reasonable there that is sort of true, then give yourself the mark. Just 1 mark for that last bit. And I reckon it's 2 marks for each of those. question 10, right, it tells you it's a geometric series. So the very first thing to do is to check out here and make sure you can see those two things. Now it's all about common ratio is the R that's in that thing. So in those formulae. The first thing I would do is just write out my series. I've got the first two terms, I don't know what they are. Then I know that's 6.4, I know that's 5.12, and then it just goes on, doesn't it? And R is the number that you multiply 6.4 by to get 5.12. So to work out what R is going to equal 5.12 divided by 6.4. And if you do that, you get 0.8. So that's a pretty easy 2 marks. The first term of the series, well, all we need to do, if that's 0.8, is divide when we go the other way. Divide by 0.8 will get you the first one, divide by 0.8 again will get you the second. So the quickest way to do it would be to say 6.4 divided by 0.8 squared. However you did it, if you've got 10, you got 2 marks. The third part, the sum to infinity of the series. So at this point you look in your formula booklet and you should see sum to infinity equals a over 1 minus r, as long as the modulus of r is less than 1. So we know a now, that's 10. We know 1 take 0.8, well that's the same as 10 divided by 0.2, which is the same as 10 times 5, isn't it? It's 50. It's another 2 marks. And then we need the difference between the sum of the infinity of the series and the sum of the first 25 terms. So then the other formula that's there in the book for you is this: a brackets 1 minus r to the power n all over 1 take r. And we take our first term is 10. We know 1 take 0.8 is 0.2, and then we've got 1 take 0.8 to the what is n? It's 25. And if you pump that into your calculator, you should get 49.8111, I think it says, but I wouldn't bother writing all of that down. The only thing you need to write down is 50 take that 49.8, and then, but when you do that, actually in the calculator use the answer button instead, of that will get you it exact. That's giving me 0.1888, and I'm just writing down the first 4 significant figures just to make sure that I don't lose a silly mark here. Round up gets me 0.189 to 3 significant figures. Right, whenever you get a question with a monstrous number of marks like this, you want to take your time to make sure you're doing the right thing. And although they've given you a diagram, I would be up for drawing 1 or 2 more just to make sense of it. So we want the area of this region here, which means we need the area of the triangle. So triangle, let's call that AOC, take the area of the sector AOB. And then we also need to sort of picture the whole thing. Now, one thing I would do, when I first did this, I got a little bit surprised by the answer, but I checked it out and I had done the right thing. And the reason for that was actually they draw these things in misleading ways. But you wouldn't necessarily know that. So I'm going to sort of draw that right angle triangle again about the same. We know it's a right angle triangle because this is a radius and this is a tangent. And we know from circle theorems at GCSE that radius meets a tangent at right angles. That means that this here is also going to be a right angle when we get to it for the second part. Now, this is 1.2 radians. This here is 12 centimeters. Now, to work out the area, if instead of calling it AOC, I called it ABC, like this, there's a reason why I'm going to say this. The area of a triangle is a half AB sin C. Basically, the two sides that are either side of the angle that we know. We could do it actually by doing this one because we know this is 90, don't we? But anyway, so let's find out length B. This here is the adjacent. This here is the hypotenuse. So that means we're looking at cosine. So let's go over here for this. Cos 1.2 equals the adjacent over the hypotenuse, so that is 12 over, and I'm calling that side B, aren't I? Right, which means that B is going to equal 12 over cos 1.2. Make sure you've got your calculator in radians, and that should give you 33.1164 centimeters. Notice I'm not just doing it to a couple of decimal places at the moment, because if you do that, then you can end up being out by a tiny bit in the answer. So we've got that. And I'm now going to use this answer to help me out with a half AB sin C. So a half AB sin C is going to be a half times 12 times 33.1 is all I'm going to write there, but in my calculator, because I've got that there, I'm going to use the answer key so that I get it exact. Sin 1.2, and if we put that in there, that should give you 185.19 centimeters squared. We should write a little bit more down, shouldn't we? So yeah, 4675 or whatever, but yeah, anyway, so that's our big area. And then the area of the sector is going to be, and even though there's a snazzier formula, I do like to be really careful on this. I like to say I want 1.2 radians out of the full circle. The full circle is 2 pi, isn't it? Because 2 pi is your 360 degrees. And so I'm going to have that times pi times the diameter. So circumference equaling pi d, remember, times the diameter. Well, if that 12 there is my radius, the diameter must be 24. So that's going to cancel with that. So we just end up with 1.2 over 2, which is 0.6 times, whoa, hang on, we're talking about area, not circumference. Pi area is pi r squared, isn't it? So I should have the radius squared. So you're going to have 0.6 times 12 squared, which gives you exactly 86.4. So then the difference in the areas is going to give us the region R. So R is going to equal 185.19, take 86.4, which is 98.794 4. Always write it down to 1 extra than what you need so that you can double check that you have rounded it right, which gives us 98.79 centimeters squared to 2 decimal places. Part B, working out the perimeter. So let's make another little sketch again so that we're sure about what we want. So we've got from here to here, because this is the circle going round, that part there is the radius, isn't it? So that's also going to be 12. So this time I'm going to set up a right angled triangle because they said that that's parallel to that. Then this is 12 centimeters. We've got 1.2 radians there, and we want to know what we actually want to know, because we're trying to find, forget about the region up there now, we're trying to find ADB, aren't we? The distance of that. So I need this length here, I'm going to call X, this length here I'm going to call Y, and we know that's 12. So I know that Y, if I call this W from there to there, Y is going to equal 12 take W, don't I? And then all I need to do is use trig, just GCSE standard trig, to work out the X and the W, because I know the hypotenuse and I know the angle. So for X, X is the opposite, so that's with the hypotenuse is sine, so sine 1.2 equals X over 12, meaning that X equals 12 sin 1.2, which is 11.184, and then we also need W here, and because this is the adjacent now, that will be cos 1.2 equals W over 12, so we're looking at W equals 12 cos 1.2, so just making that little change to cos should give you 4.348. Now we've got to be careful at this point and remember that what we want is Y equals 12 take the 4.348 number, which is 7.652, I think. So then the perimeter is going to equal our 11.184 plus the 7.652 plus the bit we haven't worked out yet, which is the arc. So the arc we also need to do, and that we are going to use, we know the circumference is pi d, so the arc is going to be 1.2 out of the whole circle of 2 pi times the diameter. The diameter this time really is 24. We can cancel our pi's out and we get 0.6 times 24, which is 14.4 exactly. Add all of those up together and we get 33.236. Now that rounds to 33.24 centimeters if you're giving it to 2 decimal places, which they don't ask you for on this question, but it's consistent with that. If you went with the idea that on all these exams we're really meant to be doing things to 3 significant figures, then I'm quite happy if you put 33.2 for you to give yourself full marks on that as well. Now, before the Christmas break, we did some really quite tricky stuff with trig, and at first glance it looks like it might be one of those questions, but the key here is when theta is small, and at that point you sneak into your formula booklet and go small angle approximations, and I'm just going to write them down as well so that we've got them on here to see. Sine theta is nearly equal to theta. Cos theta is the tricky one, is nearly equal to 1 take theta squared over 2, and tan theta, just like sine theta, is close to theta. So we have got to show that that equals that. So it's a really nice question because you know when you've got it right, and that helps you to do the whole thing. If it just asked you to simplify it for a small angle approximation, you might not get all the way. There's a hint that comes up in this form here in a minute. So we start off by writing it out. And as we do so, we think, right, we're just going to be replacing everything, every trig function with one of these things up here. So sine theta is theta, tan 2 theta will be 2 theta, because that's what the angle is. Then here we've got 2 times whatever cos 3 theta would be. So if cos theta is that, it's going to be 2 times what that is, just remembering that our angle is not theta but 3 theta. So what we need to square is 3 theta over 2, and then don't forget to put that minus 1 on there. Then we simplify that to 1 plus 3 theta, already a little bit of something similar to what's going on there, and I can expand this. 2 times 1 is 2, and then when I times whatever this is by 2, that's going to get rid of the half bit underneath, isn't it? 3 theta squared, well, you need to square the 3 and the theta, so it'll be 9 theta squared, and take 1. Well, that's going to be I should have had a nearly equal sign there. That's going to be equal to 1 plus 3 theta over 2 take 1 is 1 take 9 theta squared. And this is a little bit like rationalizing a denominator now. Hopefully you can see that this is a difference between 2 squares, and that's what's going to enable us to cancel that top one out at the top. So we can factorize what's underneath, and the fact that 1 plus 3 theta is going to have to cancel out means one of those brackets is going to be plus 3 theta, and then it'll be 1 take, so that we get a negative amount of this. 3 3s are 9, aren't they? So 1 take 3 theta there, and they will cancel, won't they? So, and that gives us 1 over 1 minus 3 theta as required. And that's 4 marks. And the second part is just a 1 mark. So all you've got to do is say 1 take 3 theta is going to be nearly equal to, because it's small, you can assume that it's got, well, how small can it be? I remember Alex asking that question. Well, it really small. What's the smallest thing it could be is 0. So that's what we're saying. It's nearly equal to 1 minus 3 times 0. And 3 times 0 is 0, isn't it? So 1 divided by 1 is 1. So if you've got 1 as your final answer there, you can give yourself a mark. And that is that. Let me know how you got on, please.